Hi Grade 12s, this is the first video to start looking at paper 1 from your mock exam. So you can see that I've uploaded it to this section on OneNote. So I've got each of the papers, there's like a blank copy of it. There's one that I've called worked, so there's a few notes that I want to put on there based on what you did in the mock, and there's probably a few questions that we're going to have to look at together, so I'll put those on here. And then underneath that is the mark scheme. So you can open that and you've got the mark scheme that the examiners would have had access to and the one that we used for marking your work. So this was paper 1. These were in the wrong order. Remember, you started with paper 3, but this is paper 1. This should be an exam that I hope you go into fairly confidently because you know there's going to be quite a few questions. 15, 16, 17 questions, and you're definitely going to know a lot of the topics because, there's so many different questions. It's not like you're stuck on one question for half an hour and it's a topic you're not familiar with. There are going to be questions that are in your favourite, most confident topic. All right, without further ado, question 1. Question 1 should have been a really straightforward question. It was gradients and equations of lines. So I've done A and B. A, the gradient is 3. B, the gradient is negative a third, and C, I've started writing down the equation. It is, y equals negative a third x plus b, but we can see that the y-intercept is at coordinate B, which is the point 2. Is it? Oh, hang on, nope. Coordinate 4, there's B. They're in the same order. A, B, C, the word respectively means that they're in the same order. So that point is 0, 4. So we can write that down. That's easy enough. But the reason I wanted to talk briefly about this question is because people threw away marks they didn't need to. And these are the kind of marks I'd like to make sure we're getting. So it says, find the equation of the line. Yep, we've done that. Give your answer in the form ax plus by plus d equals 0. So that's the first thing. We need to make sure that all of our terms are on the left-hand side of the equation and 0 is on the right-hand side. And if you can, write them in the same order. The x term, then the y term, then the constant. So I'm going to do that. A third x plus y minus 4 equals 0. Okay, so I've given my answer in the correct form. It then says where a, b, and d are integers. Integers, hopefully we know, are whole numbers. So a is the coefficient of x, b is the coefficient of y, and d is that constant. Check your equation. Oh no, we've got a third in front of x. So we're not doing that part yet. So I'm going to multiply the whole thing by 3. So each term gets multiplied by 3. And the equals 0. The 0 gets multiplied by 3, of course, as well. And there we go. So it's a tiny bit of extra work, but in terms of like maths concepts, this is much easier than drawing a phase portrait. So I know this is only 1 mark, but we want to make sure we're not losing these kinds of marks. Okay, question 2. Question 2 asks you to use the trapezoidal rule. So you've got to make sure that I'm not expecting you to memorise that. I wouldn't want you to memorise it. Make sure you go into your formula guide and you're looking it up, and that you're copying it down correctly. Because as long as you do that, you should be able to, get all the marks for part A. They've given you the width, they've given you all the values, you just need to substitute into a formula. And actually, part B is the same thing. Find the percentage error. These are both in your formula guide. So all this question is really doing is checking, can you locate the correct parts of the formula guide? Can you substitute numbers into it correctly? And if you can, you've got 5 marks. An easy 5 marks. Those are the easy ones are the ones we definitely want. Question 3. So this was a functions question. You're given a function, you're given its domain. You're asked to find the range. And most people did pretty well. Graph it. You can find the y values from your graph, and you express your range. Typically, you should express your range as the left hand could be y equals, in this case it's h of x, and then some sort of inequality. Okay, so I don't actually know what the actual answers are, but it should be given as an inequality. It then goes on to talk about the inverse function, which they notate with h to the negative 1. That's our standard notation. And the bit that I wanted to talk about was question 3, because this caused lots of difficulties. Write down the range of h negative 1. So just a quick reminder, if we have a function and the inverse, the domain of the function is equal to the range of the inverse, and the range of the original function is equal to the domain of the inverse. So write down the range of the inverse function. That means it's the same as the domain of the original function. So we can write it down. The domain was given to us in the question. Here it is. So we can write it down. Are using the same notation as they have, h to the negative 1, and we're going to put 14 and 4. Okay, so that's just a brief reminder about that one. I think we're going to do question 4, because question 4, it didn't go so well. I think there were quite a few people who dropped marks on it, so it's probably worth us looking at. If you're looking at question 4 and you got all 6 marks, please skip. So we've got our 4 points. You can see that point D is a bit of an awkward one in terms of the coordinates. It's not like on whole numbers. All distances are measured in kilometres. That might be useful. The dotted lines represent the boundaries of the regions patrolled by the fire warden. At each station, the boundaries meet at P and Q. Okay, the new station will be located so it is as far as possible from the nearest existing station. Okay, so we're looking for the one that's the furthest away from the nearest existing station, and we need to show that it's P. So let's start with P. We are looking for the distance from the nearest existing station. So there's A, B, C, and D. C, just visually, is the furthest. I don't need to worry about C. I then need to look at the distance from P to A, P to B, and P to D. P to A and P to B are the same distance. Okay, but for all of these, we can use the distance formula from the formula guide, or for those of you that are quite happy just kind of thinking about right-angled triangles, you can do Pythagoras' theorem. Okay, so we can go through and we can find PA. I know that we should be doing it down in the answer booklets, but that doesn't work so well when we're going through questions. So I'm just going to do them up here. PA squared is 4 squared plus 4 squared. That is 32, which is also PB squared. Okay, do the same for PD squared. And then we're going to have to compare the distances from Q. So looking at Q, I can see from Q, I don't need to worry about A. It's not the nearest station to Q. So I'll ignore A and I'll look at D, C, and B. C and B are the same distance from Q, so really I find one of those and I find the distance from D. And then I'm comparing what is the distance to the nearest existing station. We want it to be the furthest. So is PA or PB or PD further than the Q stations? I'm not sure I'm going to do all of these, but let's just do QB and QC just to give us an idea. So 1 squared plus, that's what I'm doing, 1, 2, 3, 4, 5. 5 squared is 26. Okay. I think QD also ends up being 26, and I think PD is the same as PA and PB. So we can say, oh yeah, 32 is bigger than 26, therefore P is farthest from its nearest station. There was quite a lot of work to do, I think, to get those 3 marks. Reading the question carefully is important with that one. The Voronoi diagram was also not done very well, so we probably won't spend as long on it, but worth doing. So we're adding in point P as a station, and we're going to finish off the Voronoi diagram. The edges defined by the perpendicular bisectors of AP and BP have been added. Yep, those are the two bold lines. Write down the equation of the perpendicular bisector of PC. So PC, the perpendicular bisector will go through there. It's a vertical line, it goes through 14, it is x equals 14. And that is one of the lines that we would be including. And it's going to go up to where it intersects here with this bisector of CD. So that's going to form part of our new boundary. And then, of course, we're just going from there with a ruler across to there. Okay, and if you want, you can then erase this bit or just make sure it's really bold. Or if you like, you can even shade the region you want. Okay, and that has drawn in the missing boundaries around P on the diagram.